Hi, this is a tutorial on using part-part and part-whole ratios. Let's take a look at what those two different types of ratios are before we get started on the problems. The part-part ratio compares a part to another part, like speeders to non-speeders. There are two different groups that are being compared to each other. You cannot use fractions or percents with part-part. With part-whole, you're comparing a part to the whole, like speeders to total drivers. So in the group total drivers, some of them are speeders. Because of this, you can use fractions and percents. So let's look at a sample problem. If I have a ratio of 3 boys to 4 girls, I'm comparing two different parts, so it's part-part. If I wanted to switch this to part-whole, I could say that I have 3 boys to 7 students. Because if I have 3 boys and 4 girls, that must mean that I have 7 students total in this ratio. I could just as easily have done 4 girls to 7 students. Because I haven't been given a problem yet, I have no way of knowing which way I'm going to need to write it. Now, let's take a look at the fraction percent issue. If I had written my fraction on the left-hand side, where it's part-part, as 3 out of 4, I would essentially be saying that out of 4 girls, 3 of them are boys. That doesn't make any sense. And because that doesn't make any sense, I definitely can't turn it into a percent and say that 75% of them are boys. And if you look at the numbers, you can see why. Clearly, in this situation, I have more girls than I do boys. So how can I possibly have more than half of them be boys? So that, again, does not make any sense. What I am allowed to do, however, is now that I've switched over to part-whole, I can say that I have 3/7 that are boys, because out of 7 students, 3 of them are boys. Now, unfortunately, 3/7 is not one of our benchmark fractions, so I don't know that one off the top of my head. But I know if I do top divided by bottom, I'll get my decimal. So I do 3 divided by 7 in my calculator, and I get 0.4285 and a whole bunch of other numbers. I don't need all of those. I only need the first 2. So I draw my line after the first 2. I see that this 8 here is going to bump the 2 up, so I'm going to do 43%. Now let's actually try this out based on a real-life problem. There are 2 girls for every 3 students in the class. If there are 36 students, how many of them are girls? So let's take a look at what's happening in this situation. I'm comparing girls to students. At no point do they mention boys, and they don't ask about boys at any point in the question, so I don't have to include them at all. And luckily, it's already written as part-whole, because in the group of students, 2 of them are girls. So I just need a simple ratio table to solve this problem. I have 2 girls for every 3 students. Just like I taught you before, you put your goal at the end. So I'm trying to get to 36 students. Now, it is quite possible that I may be able to get from 3 to 36 in one step, and I can. But not everyone would be able to do that. So you need to make sure you include those extra spaces in the middle, just in case you want to go to, let's say maybe I want to go to 6 first, because I know that I can double. And then if I double on the bottom, I double on the top, so I get 4. So that means that 2 compared to 3 is equivalent to 4 compared to 6. Oh wait, and I know I can do 6 times 6 will get me 36, so I can solve the problem. So 4 times 6 is 24. The question is, how many are girls? So So 24 is my answer. Now, if I had just seen that I was going from 3 to 36 and recognized that that was times 12, I could have done the same thing on the top. And 2 times 12 is 24. So it really depends on which multiplication facts I know, how quickly I can do the problem. Now, not everyone likes ratio tables. So the other strategy that we know is the one where we actually use the ratio symbol, which is the colon, which you guys know is the bad date strategy because of the bad date video that we watched in class. So let's suppose we were to do that strategy. I would still include labels. I'm comparing girls to students. And the colon represents the word to. So I'm comparing 2 girls to 3 students. And I'm trying to get to 36 students. I'm going to put that on the right-hand side. And I just need to think about how to get there. Now, we already talked before, and if I know my multiplication facts, I know that it's 3 times 12. But I could have done it in more than one step. I could have taken as many steps as I needed to solve the problem, as long as I get the right answer when I show my work. And 2 times 12 is 24, so there's my answer. I could have even done a ratio table. I could have even done a fraction bar. I see that there are 2 girls for every 3 students in the class, so that means that I have 3 parts to represent the 3 different types of 3 different students in the ratio. 2 of them are girls, so I'm going to label girl and girl. So clearly this is boy, even though I don't need to know that. And because I have 3 parts, and I'm spreading my 36 out evenly, I'm going to fit 12 in each part. And I want to know only the girls, which is 24. So again, with any of these problems, I have multiple strategies I can use that will get me to the answer. And regardless which strategy I picked, I still got 24. So there are definitely 24 girls. And if you're ever unsure, try doing the problem a couple different ways and see if you still get the same answer. But always use labels. Labels are key. In all 3 versions of this problem, I included labels. If you have labels, you are less likely to make a mistake. And if you do make a mistake, you're more likely to catch it and be able to fix it in time. Now the problems are going to start to get harder. For problem number 2, the ratio of long hair to short hair in the class is 4 to 5. So first off, we need to think about what it is that we are comparing. We are comparing long hair to short hair. Now, when it says 4 to 5, I need to make sure I know which number goes with which word. So I have to pay attention to the order that I said it. Because it said the ratio of long hair to short hair is 4 to 5, that means that 4 is the long hair and 5 is the short hair. Now, because the next thing says that there are 36 students, it's referring to all students, not specifically long hair or short hair, but all students in general. So, I actually have a 3rd row to my ratio table. So I call this a triple ratio table because I started off with a part-part situation. I had long hair compared to short hair, but I need the whole in order to solve the problem. So a triple ratio table will get me there. So I'm going to start filling this in. I see that if I have 4 students with long hair and 5 students with short hair, I have 9 students currently. Then, just like any other ratio table, I need to put my goal in there, and my goal is 36. And just like before, if I know my multiplication facts, I can figure out how to get there. 9 times 4 is 36. So 4 times 4 is 16. And 5 times 4, even though I don't draw the arrow, I know I'm doing the same thing, is going to be 20. Just to check my work, I need to see that my things are adding up correctly. So 16 plus 20 does indeed give me 36. So far, so good. And now I need to solve the problem. how many of them have short hair? There are 20 students with short hair. Now, again, just like before, if I don't like ratio tables, I don't have to use them. I could go back to the bad date strategy again. I could say, well, if I have long hair to short hair, that's 4 to 5. But again, it's mentioning total students. So I'm just going to write total over here off to the side. Right now my total is 9. And just like we did in the ratio table, we're trying to get to 36 students. So that's going to go in the total. And I'm trying to get there. So I'm going to do times 4. But I could have done it in more steps, could have done it in just the one. It doesn't matter. I'm doing times 4 for everything. Try to keep everything equivalent. So I'm going to get 4 times 4 is 16. 5 times 4 is 20. And again, my answer is 20 for the short hair. And you know what? Just like last time, I have yet another strategy I can use. If I don't like ratio tables and I don't like the bad date strategy, I can also switch to my fraction bar. So all I'm going to do is look at what it's saying. It's saying long hair compared to short hair. I have 4 students with long hair for every 5 with short hair. So I have a long-haired person, a long-haired person, a long-haired person, a long-haired person, a short-haired person, a short-haired person, a short-haired person, a short-haired person, and another short-haired person. Now this could take a really long time if my ratio was bigger, but for what we're doing right now, this is just fine. So I have 4 long-haired for every 5 short-haired. Then I turn this into a fraction bar. Draw the box around it. Draw the lines separating them. So in my fraction bar, I end up with 9 total pieces. Just like before, I mentioned that I had 9 total students in my triple ratio table and my bad date strategy. I end up with 9 parts in my fraction bar. So because I have 9 parts in my fraction bar, I need to take my 36 students, divide them into 9 parts evenly, which I could have done in the calculator. Would have gotten 4 for each part. But the only parts I care about are the short-haired parts. And here I have 5 groups of 4, so I have 20 students with short hair. Again, as you can see, regardless of the strategy that I pick, I still get the same answer, and I'm still showing my work, and I'm still including labels. So it doesn't make a difference as long as I do all of those things. Now we're going to end with a problem that's really not too bad, even though it sounds terrible. We see that there are 36% of the students that have a bagged lunch for the field trip. So they already packed their lunch, they already have it with them. There are a total of 242 students on the field trip. So I need to figure out how many of them have to buy lunch. So as you can see, we're talking about a percent. And because we're talking about a percent, it must already be part whole. Because as I taught you earlier, you aren't allowed to do percent for part. So I have 36% have a bagged lunch. I need to figure out how many people have to buy lunch, which is the opposite of packing your lunch ahead of time. So the trick is, I know that regardless of what's going on, I always have 100% total. So if I have 100% total and I subtract the 36% that I already know, I'm going to end up with 64% left over. So that 64% must be the percent that buy lunch. But the question didn't say what percent are buying lunch. The question said how many students are buying lunch. So I need to find out what is 64% of 242. And this is one of those problems where a calculator is definitely going to be helpful because both of my numbers are very ugly. I know that of simply means multiply. So I'm going to take my percent and I'm going to turn it in to a decimal, because not every calculator has a cool little percent button like the ones we use in class. So 64% is actually 0.64 as a decimal, and I multiply that by 242. And I get in my calculator 154.88. And I could leave my answer just like that if I wanted to, or because I know I'm talking about people and I don't need an exact number, I'm just going to say that it's about 155, because that's what I get when I round. So as you can see, sometimes I'm giving you a situation where it's already part whole and you have less work to do. Other times it's part, and you do need to include a little bit of extra work, because you may need an extra column or an extra row or just some extra part in order to deal with the situation. Because part, again, you cannot do percent and you cannot do fractions. Okay, good luck.